Thank you so much, Winnie. So just a brief on who we are. ICPAC is a regional climate center designated by the World Meteorological Organization. We serve 11 Eastern Africa countries, 8 IGAD member states, and 3 East Africa states. Just a brief on the historical Super El Nino years. The key term now is Super El Nino, but I'll be having both Super El Nino years and just El Nino years. So like we've been told what a Super El Nino is, so I'll not repeat that. But what I want to just point out is what were the magnitudes of the index during the past Super El Nino years. So as we can see, just indicated the past three, the most common ones, 1982-83, 97-98, and 2015-2016. So we can see the Nino index during this year. These 3 years were way above 2 degrees above the average. Then when we talk of El Nino, specifically over the Eastern Africa and specifically over the during the October to December season, we normally talk about the Indian Ocean dipole because one, Indian Ocean dipole is a very critical modifier on how El Nino is going to impact the rainfall patterns over the Eastern Africa region during the October to December season. But we'll be focusing on both how El Nino affects rains during both the June to September season and October to December season, which are the 2 of the 3 main rainfall season over the Eastern Africa region. So the June to September season is significant over the northern sector of the region, while the October to December season is significant over the equatorial and the southern sectors of Eastern Africa region. So a general understanding of how El Nino impacts rainfall patterns during these seasons is that El Nino causes or leads to depressed rains during the June to September season and an enhanced rainfall pattern during the October to December season. So why or how does El Nino lead to depressed rains during the June to September season? A bit of science. So we have 3 key ways in which this phenomena leads to depressed rains. One is that it weakens the tropical easterly jet. Basically, the warm sea surface temperatures over the Pacific that we know we monitor the El Nino triggers what we call the Rossby waves, basically eastward moving waves, and that causes convective activities. So once these ones are triggered, it weakens what we call the tropical easterly jet, and therefore this weakened jet reduces convective activities during the June to September season over the northern sectors, and therefore that is one way that El Nino causes depressed rains over the northern sector. Then other way that El Nino causes depressed rains is because it reduces the moisture flow from the Atlantic Ocean as well as moisture from the Congo Basin. We have all been hearing about the Congo air mass and all that. So when we have this warming over the Pacific and all that triggered Rossby waves and all that, the low-level westerlies that is from both the Congo and the Atlantic are weakened, and therefore we have a low moisture influx into the region and therefore depressed rains. We also have the weakening of the East African low-level jet. This is also associated with the rains during the JJAS. But when we have El Nino happening, this low-level jet is weakened, and therefore moisture transportation towards the northern part of Eastern Africa is reduced, and therefore depressed rains. So this is an example of what has happened in the past during the 2015 El Nino event that most of us are quite aware of. We've seen that this was one of the worst drought years in the northern sector, specifically over. We've had a lot from Ethiopia, where most of the livestock and other impacts were felt. Livestock were lost, and other associated impacts were felt. And this is what we were able to see from what was recorded in terms of rains. So you can see central and to the northern part, specifically over the highlands of Ethiopia, were dry during that 2015. We also had dry conditions in northern parts of Uganda, which is basically an active area during the June to September season. We also had dry conditions in South Sudan and Sudan, also Eritrea. Then going into the October to December season, like I said, most of the time when we talk about El Nino or La Nina during the October to December season, we find ourselves talking about Indian Ocean dipole. Why? Because most often when we have an El Nino, it is associated with a positive Indian Ocean dipole, but there are other years when we have an El Nino and a neutral Indian Ocean dipole, but most often we have an El Nino with an Indian Ocean dipole being positive. So what happens during these years when we have a strong Indian Ocean dipole and an El Nino event? What happens is that most parts of the Eastern Africa gets enhanced rainfall. We have most parts of the region receiving significantly heavy rains. But when we have El Nino and no Indian Ocean dipole or a neutral Indian Ocean dipole, the wet conditions or the enhanced rainfall is only concentrated over the coastal areas, specifically over the eastern Kenya, coastal parts of Tanzania, and central to southern parts of Ethiopia. But if you go inland into the region, it gets a bit drier. So a case example of what has happened in the past when we had both El Nino, whether it's a super El Nino or just a strong El Nino, in 1997 and 2023, this is what we were able to record. The first map shows what was observed in OND 1997. And as you can see, most parts of the region, or basically like the entire region, recorded enhanced rains. And on the second map, this is what was observed in 2023 when we had a strong El Nino and also a positive Indian Ocean dipole. Most parts of the region also recorded enhanced rainfall, with only a few areas in Ethiopia, Kenya, Rwanda, Burundi, Tanzania recording normal conditions. So that's all from us. Thank you so much. Over to you, Winnie.